Physics, Newton's laws B, P22B, describe how such examples, the one we discussed about earlier, involve interactions between pairs of objects which produce a force on each object. So we're looking about interactions, that means pushes or pulls between pairs of objects. This is the situation when we introduce Newton's third law of motion. We'll discuss about it a little bit later also. So Newton's third law of motion, for example, we have this child, it's on a skateboard and it has a ball in his hand. When he's throwing the ball forward, this ball creates, you're acting with a force in order for this ball to move forward. But this force that you're acting on the ball, it's also creating a reaction force from the ball on your hand, which means that the boy with the skateboard is going to be moving backwards. So that means there is an action, the force that you put on the ball, that's moving the ball forward, and there is a reaction, the force on you, and because you are on a skateboard, it's gonna push you. Backwards. If you were sitting standing on the floor and not on a skateboard, you're still going to feel that force, but probably you won't be moving backwards. For every action force, there is a reaction force equal in strength and opposite in direction. For example, that means that ideally, if you were on an iced lake, in the middle of an ice lake, and you cannot move because you're on the ice, so there is no friction, but you had like a very heavy bowling board, for example, or a very heavy backpack. Now, if you're gonna throw that bowling board or the backpack forward, because there is no friction under your feet, that throw forward, that force that you'd be pushing to throw that ball forward, would be enough to push you all the way to the end of that frictionless ice lake. So you'll be able to get off the lake. Forces exist in pairs. That means exist as two. One acts in one direction and the other one acts in the opposite direction. One is positive and the other one is negative. Now in this situation, let's say the one that's moving to the left is negative and the force to the left, the action, the force on the ball is negative. The force to the right, the reaction, the force on you is positive. They will have the same value, that means they will have the same strength, but they have opposite directions, that means they have opposite signs. One has a negative sign, one has a positive sign. The same thing happens here. We have a balloon, and balloon is filled with air. Now, if you untie the balloon, the action would be, so that's the first force, the air rushes out of the balloon. So it's pushed out of the balloon, oriented downwards. That action creates a reaction, which means that the balloon is pushed upwards, and it will move upwards. So one of the forces pushes the air downwards, and the reaction force to that one pushes the balloon upwards. So one acts in one direction and the other one acts in the opposite direction. One is positive, the one that goes upwards is positive, the other one that goes downwards is negative. They have the same value, so the same strength, so the same force is pushing the balloon upwards as it is pushing the air downwards. So for example, if let's say 5 newtons is pushing the balloon upwards, well, there will be 5 newtons pushing the air out of the balloon. Another example would be like a hammer that's hitting a nail into a surface. So the force of the hammer on the nail, so the force of the hammer is pushing the nail to the right, but at the same moment the nail is reacting with another force which is exactly equal. We see the arrows are exactly the same, is equal to the force the hammer is acting with. So the force of the nail on the hammer, it's exactly the same as the force of the hammer on the nail. Opposite directions, to the right would be positive, to the left would be negative, but the same value. So let's say if the hammer is hitting the nail with 3 newtons, the nail will hit back with 3 newtons. Think about here like you're clapping your hands. If you're clapping softer, well, you feel on both hands a softer impact. As you're clapping harder, you're going to feel a harder impact on both hands. So this is the fact that the 4616 pairs, 2 of them, they have exactly the same value, they have the same strength. The only difference is that one is going to the right, one is going to the left.